everybody, it's me, Miss You, and we're going to be working on the Pear CAM right now. First, we're going to go to define our variables. We're going to go to add variable, and the first variable is the nominal dimension. We're going to call it D for dimension, and it is 2 inches. Next one that we're going to do is going to be the hole, and that's going to be 1/4 of an inch. And of course, we're using a square that's 1/4 of an inch by 1/4 of an inch. And the extrusion is also going to be 1/4 of an inch. Great. And so here we are. The extrusion is done. The variables are done, and we're going to go to the front view. We're going to go to front, and we are going to start off by drawing. We're going to draw some arcs. We're going to do a top arc, a bottom arc. Then we're going to join them with tangent lines. So here we go. We're going to go sketch, arc, and the arc should be almost a circle. My first point, my second point, and we're going to go just like that. I'm going to make this point coincident with the center point of the arc coincident with the center by using the coincident constraint. Here we go. They are coincident. I'm now going to also dimension it to be, I think it's, the arc is D over 2. Okay, D over 2. Okay, our first arc is done. The second arc we're going to do is in the opposite direction. We're still going to use the 3-point arc, and we're going to go 1, 2, and this is what it's going to look like. 3. I'm going to dimension it. It's D over 8. Originally, I did circles and trimmed it, but I found this way was more consistent. I was able to get it right because when I trimmed it, sometimes the radius and the diameters did not match. So I figured let's keep it as a radius because that was what the drawing has. Okay, we're going to now do a coincident constraint. Again, this point goes on the center line, moved over, great. And now we have 1/2 inch, D over 2, or actually 1 inch between the two centers. Okay, I'm going to go D divided by 2. Great, and now we're going to draw a line that's tangent to both circles. I'm going to somehow start something like that. Okay, this is kind of like what it's supposed to look like. And I'm going to create the tangent constraint. This is the tangent constraint, and the line and the circle. And there we go. That's where it's tangent. That means that the line just barely touches the side of the circle. Now I'm going to have this side just to make sure it's tangent. I'm doing this and that. Okay, and those are tangent. Excellent. And now I'm going to trim them. And it's starting to look like the image that we're copying. Now let's do the second line. Okay, let me use the get out of line draw, use the tangent constraint, line to circle. Great. Line to other circle. Okay, and that's where their tangent. Everything went black, so we know everything's accounted for. And now let's just do some trimming. Okay. And we are all set. Now we're going to create the center point rectangle. I'm going to go to the center, create the rectangle. Now we're going to dimension it. And we're dimensioning it as the whole, 1/4 inch. The whole, it's 1/4 inch. Okay. We're going to go isometric. And it looks good. The next step is we're going to extrude. So let's accept the sketch. I'm going to take it. We're going to extrude it. And we're extruding it by 1/4 inch, but we already wrote it. And here we go. That looks very good. This is what the Pear CAM looks like. It's exactly like our drawing. And let's go the isometric view. Let's change it. And we will call it Pear CAM. Right click, rename Pear